Ready?
Whenever, yeah, I'm ready.
All right. Well, welcome back to the Dreamers Podcast. We're back with episode 13, and today we're doing our first virtual podcast. Hopefully, you guys enjoy it. We're continuing our mission of bringing you guys stories of leaders who are shaping the future of medicine, science, and education. As always, I'm Muni Rahman.
And I'm your co-host, Asfan Musa, and today we're honored to be joined by Dr. Carolyn Smith. She is the Senior Vice President and Dean of Research at Baylor College of Medicine. She is also the Dean of the Graduate School of Biomedical Sciences and Vice President for Education Affairs.
With over 100 peer-reviewed publications and more than 2 decades of continuous NIH funding, Dr. Smith's work has shaped both molecular science and the next generation of biomedical leaders. Dr. Smith, welcome to Dreamers Podcast.
Welcome.
Thank you very much. Great to be here today.
Perfect. We'll go straight into our first segment, Dr. Smith. This is more about the beginning for you. Before you were ever a dean, professor, or a research leader, who did you need to become as a person in order to succeed in science, and what internal traits mattered most early on to you?
So I think one of the things that I like to think about that led me into a career in science was curiosity. Curiosity about how things worked, um, how how science and nature worked, but also, how things with people worked. I love puzzles. I still love puzzles. So the intellectual challenge of taking something that's not readily apparent, studying it, thinking about it, figuring out how to get to solutions. I think it's something that many scientists, many people in academic medicine find as one of their core traits. They want to learn something and be able to apply it, and solving critical problems is a key part of that.
And did you always wanted to get into academia in the science field, or was there a time where you were leaning more towards medicine or some other field?
So probably like many kids, my mom had a scrapbook of me growing up through the grades, and my scrapbook says I wanted to be a pediatrician till I was in about the third grade, and then it switched over to being wanting to be a scientist. I think as I got older, that decision was solidified for me. In part, as a scientist, I like to define and answer my own questions. And as I thought about practicing medicine, certainly when you're in an academic medical center, you really do get to do that. But when I was growing up, my vision of a doctor was, our family doctor. And that didn't seem to me like they had a whole lot of room to, define the questions and the problems that they wanted to work on. So I leaned over to science pretty early. I had a family member who greatly encouraged me, gave me books about science writing and early chemistry and things like that when I was probably in middle school age. And by the time I was a junior in high school, I was working in a university lab. So it's been a transition, but one I got started in very early.
I love that. And my next question to you is, what part of your personality became your greatest asset in navigating academic medicine? And which part did you have to reshape along the way?
Um, I think the piece that helps me a good deal and has throughout my career is mostly an ability to keep relatively calm and focused on a problem. I like to spend my energy thinking and solving problems and not so much around all of the things that sometimes surround problems. So I try and be a little bit efficient with what I spend my time on, and where I sort of spend time, thinking and the after hours types of things. It's the question, the puzzle, the issue to solve that generally I tend to focus a little bit more on. So I think that's been helpful. As I've approached my career, I've always been interested in how organizations work, how institutions work, even how does science work? Why did people pursue these questions? why this experiment came before other experiments. But also, I continue to be really interested now on how, complex organizations of people and scientists and institutions and so forth, how they all work together. And that's very helpful as I do my current work, trying to bring together various groups from different perspectives and try and get to solutions.
Amazing.
Amazing
And
answer.
looking back, was there ever a moment where your identity as a scientist shifted from learning the field, working with a lot of experts, to finally owning your place within it, when you started realizing, okay, I am built for this. Now I can overtake all the experience that I've had and start making my own decision in this field?
Yeah. I think that comes naturally as one progresses through your career. I think when you're a beginning scientist, sometimes you're very apprehensive or sometimes you're overconfident. It can be one of those two things. But I think as you move along, you do your training, you get your postdoctoral fellowship done, you get your first position as an assistant professor. Those are all transitions where hopefully one is gaining confidence along the way. And then having success in those areas also sort of helps, I think, me and others who have gone through that similar path of really kind of thinking, yep, I belong here and I can do this. Of course, as careers evolve, you keep doing new things. And so there's always that constant, at least I hope for, that constant challenge of new things to learn and, to kind of feel like I've mastered something else and ready to take on the next challenge.
I love that. Great advice. And we'll move on to our next segment.
Now, I want to specifically talk about like the scientist's mind, I guess.
Mm-hmm.
When you're dealing with like a tough scientific or institutional problem, like what's going on in your head? Is it like more structured thinking, intuitive, a little chaotic, or like is it a mix of everything?
I think it's a good mix of probably all of the above. Too much of any one of those is not likely to get you to a solution very well. So what do I mean by that? I think, being process driven in your approach to things sort of helps to identify problems, resources, um, perhaps gets you to understand other factors that might impinge on the question or the thing that you're trying to do. By this, but in parallel, if you take a very traditional approach to questions and problems, you're not likely to come up with that creative solution. So allowing yourself to think outside the box about other ways to maybe get to what you want to do, whether that's, you design a completely different experiment, hopefully addressing the same question. In work and leading areas, you might want to get a certain thing done. The straight path may not be the path of success. You might need to take a couple of side steps, get some things working there, and then be able to push forward. I think the last thing you mentioned was chaos. So chaos, probably not the thing that I would strive for right up front. But sometimes a little bit of chaotic thinking kind of helps you and get into that outside the box mold. So I would say from that perspective, it can be kind of useful.
Yeah, we had Dr. McDavid on the podcast last month, and he talked about how sometimes science can be either orchestra or like a jazz band, where it's
Mm-hmm.
just you never know what's going to happen in a jazz band, and sometimes you have to be unorthodox. So I really do like your answer for that as well. And then I kind of talk about a moment when you were maybe working on a publication and the results didn't really align with what you expected or believed in. What did that teach you about the scientific process?
Oh, yeah, that's a great question. There was a point in my career where we were working on something and we started getting data that was the complete opposite of what we expected it to be.
Oh, wow.
Um, and I had a really talented postdoctoral fellow at that time who was, I give her a lot of credit because she was very careful. She came to my office many times to tell me that the data is telling us the opposite thing. Um, and it was through working, with really, I think, well-designed experiments that she did. They were really well controlled. And it actually helped us at the end really prove and make ourselves comfortable in the conclusion that the protein that we were studying really had opposite effects. It depended on the context in which the protein was working. It could turn things off, it could turn things on. In many ways, it was a great experience because it truly was kind of getting back into the method, really using the data, really letting yourself try and look at the experiment and interpret them in the least biased way you could, that allowed you to see this other possibility. And it turns out that's a great way to think, because many times in biology, many times in working with people, there's not just one way. People don't always behave the same way. Biology doesn't always behave the same way. Diseases don't always behave the same way. You have to sometimes really open yourself up to thinking about them, that they might be working in another way, and you have to look for it. You have to design experiments so you can see it and you can test for it. And so you can really get to that understanding of
I love that answer.
different
Really good
functions.
answer. Yeah. And then I guess last question from me will be, in an era of AI, specifically now data and automation, what human quality and scientists do you believe will become more important with these new surfacing technologies?
Well, I tend to think that the most important, or one of the most important characteristics of scientists are curiosity, as I've always mentioned, but critical thinking and reasoning. And a lot of that is looking at data and not necessarily seeing only the most obvious interpretation, but sometimes more hidden information that's there. I think AI can be great. It can pull information, it can synthesize, but that human curiosity, that intuition, that deep knowledge of data and how experiments work and the biology that you're studying, sometimes that gives you that insight, those aha moments that really come from synthesizing many different things together that you wouldn't necessarily connect. So I'm curious to see what the evolution will be with AI as we continue. I think it's going to be an important tool. Definitely want to be able to use it in research activities. It does have great potential to save a lot of time and energy on things that, maybe just aren't so important or so interesting to do. But that spark of human intuition and curiosity and creativity, I think we really still need that. We need to nurture it. We need to keep that forefront to help us really move science and medicine ahead as quickly as we can.
Yeah,
That's
because
also,
yeah,
that's
go
also
ahead.
the reason why a lot of journals who do let authors use AI in writing their papers or manuscript have it clearly mentioned that first, I mean, you have to let them know that you're using AI, and then secondly, AI cannot be an author, so all the
Mhm.
ownership of the material would still be yours. So if anything does get messed up, it's on you. It's not on AI.
Yeah,
That,
it's a
that's
tool. Yeah,
it's a tool.
yeah,
It's a great tool. I'm
yeah,
sure as time goes on, we will only find out more that it can do for us. But your example about authorship is, I think, spot on, right? The work, the conveying of the idea, that's still the human piece, right? And we have to, as the humans conducting the research, be responsible for everything that we report.
Correct.
yeah. And I think thinking outside the box, kind of how you mentioned, is AI really thinks inside the box. Human curiosity is what kind of branches on to these new discoveries that we always see, and that's what I think AI. Maybe in the future we don't know, but for as of right now, I feel like it's a great tool to use, and we definitely use it all the time for school. Yeah, and then yeah, we come on to the next segment.
Sounds great. And now, Dr. Smith, I want to talk about your leadership skills. As someone who oversees both research and graduate education, what is the hardest type of decision you have had to make in the recent years that most people outside of leadership roles may not be able to understand?
Well, I think, the last 5 or 6 years have been a very interesting time.
Correct.
There are circumstances that arise. So COVID is the obvious one. But there are many others where, there's a problem put in front of you and there is no playbook, there's no solution. And you sometimes have very limited information as you go into these things. And so you try and do the very best you can. But everybody's got different perspectives on this. So, I would call the times when we were opening up after COVID, and we had, a great diversity of opinion on how fast was too fast, how slow was too slow. And, you were trying to balance off the desires of people to get back into laboratories and do their research, to engage people back into that creative process, which is not so easy to do when everyone's in a different place. And so sometimes you just have to, I think as a leader, sort of articulate the direction you're going, the decisions you're making, offer appropriate rationale for why we're doing certain things. You always have to be prepared that not everybody's going to agree with you. And I think hearing other opinions, being respectful about them, is important. But as a leader, if you're swayed too much by the variety of opinions, it gets very difficult to move forward and make decisions and kind of advance whatever it is you're trying to do. So it's that balance, careful sort of thinking and rationalization for things, and then being willing to, tell the community this is what we're doing and why, and help them understand. And sometimes there will people that, won't agree, and you just have to be prepared to continue to work with those folks and still move forward.
I love that answer. Thank you. And have you ever experienced a situation where your role as a scientist conflicted with your responsibilities as a leader? And how did you navigate that moment?
Sure. So I think scientists are creative, independent, innovative people that often, they have a scientific goal, and that's sort of the primary thing that they are interested in. I get it, loved it, did the same thing. And then sometimes, more on the administrative side, you've got to come into the realities of people resources, space resources, financial resources. You have to sort of put on a sometimes a little bit more of a position of making sure that, we're being as fair and equitable across many different areas. Sometimes that's something important. And sometimes those things, of course, they are very important, but they might not fit exactly in that space of the very innovative scientific research that we don't want to slow it down for any reason at all. And so sometimes you have to balance that. As best I can, I try and find those sort of sweet spots where I like to try and think about enabling creativity to make things possible for people to really do their best work, and try and keep as much as we can the constraints, the processes, the approvals to a minimum, or at least manageable and understandable, expectable, something that one can anticipate appropriately, because I really don't want to ever, stifle that creativity. That's probably one of the harder things is trying to carry out both of those and trying to find the balance.
Looks like you're doing a great job at that. And in an era where there have been a lot of funding cuts from the administration, as well as just loss of research funding, as a leader in graduate education, how do you keep your students motivated and letting them know that what you're doing, if you are truly passionate about this, is the right move, and you will find opportunities as time goes by?
Yeah. An excellent question. And I think one that this is not the first time this has been a question in the minds of graduate students. Is this the time to launch my career? I have a fairly strong belief that, creative, hardworking scientists, no matter what the era, they will be successful. They're, I think, driven to be successful. And, when you're training in an environment where you have really outstanding resources, you can do a lot to help position yourself for a strong future by, being really good at the research that you do, try and be as creative as you can, really use the resources around you to network and position yourself for continued success in science. I really believe science is the heart of so much of what drives not only medical research, but it has huge impacts across the economy. And so I think there's always a need for really well-trained, smart, creative, critical thinkers. And so I think really I'd love to see more people with, strong backgrounds in biomedical research and mathematics, to get out and use those skills. Whether you're directly a researcher or you're applying them to other important problems, I think there's really a lot of potential for people to go out. So I'm still very bullish on the future, and I really think our students will continue to do really well.
Thank you. That is a really good answer. And we'll move on to the next set of questions now.
I want to talk about you being the dean at Baylor, and I'm sure you mentored many students and trainees as well. What's one core lesson you try to pass on to everyone about their training and academics?
I think maybe it's a two-part. I think the first one is, particularly in PhD training, you're in charge of your training. There's lots of people and resources, there's courses and all sorts of things to help people learn things and learn skills and make connections with people. But the really great thing is that you get to chart your path to figure out how you're going to advance your career. And so that really, I think, is an important message. I think it's really quite a shift from undergraduate education, where there's more of a laid out series of courses that you need to take and maybe a capstone project. But there's more structure to that. The harder part and sometimes a tough transition is to get to be to the point where you can do whatever you want. But you have to figure it out, and then you have to do it. Again, that's developing those critical thinking skills and so forth. So I think that's one important lesson. The other lesson that I often reflect on myself and try and share with our students is that as you go through this training process and as you go into your career, you get to determine what you want to do. You can try and get people to help you along the way. In fact, that's a great way to do things. But ultimately, you can't make people do what you want. So you have to work with your colleagues. You've got to work with your mentors. You've got to work with the research community. And when you can work in that system well, it's a lot more fun and you'll get a lot more done.
No, I love that answer. And I guess talking about PhD students, have you ever seen like PhD students struggle with the most in their training, maybe specifically like a group of PhD students that you've seen?
The things that they struggle with?
Yeah, like in general, I would say.
I think there's transition points in training. So I think one is the sort of learning that I'm in control of my domain, which means I've got to plan my day, plan my experiments, plan my work.
Mhm.
So that's a hard one, and I've already touched on that. I think there's another point in PhD training that's really hard. And that's when you've defined your problem, you're starting to work on collecting your data, you're setting up your model system, and experiments aren't working.
Uh-huh.
And they don't work and they don't work, and you might do it 5 times or 10 times. That can be really hard. It's pretty tempting at some point on those things to give up and move on. It is one of those things that if you can work through that scenario and learn how to make the experiment better, learn what maybe you don't understand in the model system that is impacting your results, that development of those skills of being resilient and taking failure as part of the learning journey, really critical. Often hard for people when they first encounter this. Students in PhD programs, they're generally here because they've done really super well throughout their entire academic training. So when they first get into scenarios where things aren't working, it can be kind of hard. But you can see it in students as they overcome that and they figure out how to design successful experiments. They're really those really precious sort of aha moments or sort of eureka, and those are just wonderful to see.
No, I love that answer. Especially at Baylor, I feel like training PhD students, what is the, I guess, Baylor does different in training that you maybe have seen throughout your career that you haven't seen in other institutions?
I think one of the things that we have a pretty heavy emphasis on, and I think probably more than many other institutions, is the sort of requirement for students to meet with their faculty advisory committees on a regular basis. And we've long decided to do that for, I think, a couple reasons. One, if things are going well, it's great to share your results and plan that next experiment. But the reason we always have these meetings, even when experiments aren't coming along well, is to make sure that students get the practice of talking about negative results. Things aren't working. And they learn how to work with an advisory group on how to plan and strategize to shift things around. So that's a piece, again, I think we do more of that than many institutions. And I think it's got a number of lessons and skills built into it that can be really helpful as people finish their degrees, but also continue into their careers.
I love that. And I guess our last few questions that we have is advice for our viewers. Our viewers are mostly considered undergrads, I would say. What do you think today's students most misunderstand about building a meaningful and fulfilling career in medicine and research?
I think doing something that you are passionate about is really important. Going into a career in medicine, going into a career of science, both of those are hard careers, take a lot of work, a lot of time to go through the training pipeline. And, I really believe even to this day that if you love what you're doing, it's a pleasure to have the opportunity and the privilege to study to be a physician or study to be a scientist. You can cultivate interest, you can cultivate passion. And so bringing an open and curious mind to things is, I think, great. And, pursuing careers straight out of undergraduate, I think also outstanding. This is not for everyone. And so, I think people should choose paths that they think will bring them fulfillment, will keep their minds active. And I think that's really probably one of the key things to, getting into a career path that really has a huge positive impact, right? Do something that, you find enjoyable, interesting, engaging, and you should have a good career.
I love that answer.
And my final question to you, Dr. Smith, for a student listening right now who feels overwhelmed by expectations and uncertain about their future in science or medicine, what is one truth you wish someone had told you earlier in your own journey?
So I think, when it feels overwhelmed, I think, it's good to pay attention to that. It's good to give yourself permission to feel like there's a lot going on right now. And it's also good to make a plan for how to get over that hump. And sometimes it's just giving yourself permission to work on something really hard for a while and see if you can get over the hump. Sometimes it's permission to go do something a little bit different, free your mind up, and then be ready to come back and tackle the issue at hand with a fresh perspective and some maybe additional energy for it. So, don't get discouraged. Take those challenges as opportunities to learn and grow. And I think that's a philosophy that can serve well both while you're in school and really as you get into your career and move through life.
You have great advice. Thank you, Dr.
Yeah,
Smith.
thank you so much. And I guess we're at the end of the podcast. Thank you so much for coming on. And I really loved hearing about your achievements, but also thinking about your leadership philosophy. And, just really interesting hearing from different people about their perspective on their careers. And that's kind of why we started this, is to showcase that. And yeah, go, that's fun.
Well,
And to
thank
our
you very
dreamers,
much. It was
Yeah.
really a pleasure speaking with you today.
thank you. And to our dreamers watching this podcast, remember, you don't need to have everything figured out. Focus on growth, intention, and becoming the person your future goals require. And let us know if you like this new podcast format, the virtual podcast, in the comments down below. We'll see you next time on the Dreamers Podcast. All right.
All right, we're done.
Thank you so
Thank you,
much.
Dr. Smith.
Oh,
This was
thank you so
amazing.
much.